Hi everyone, today we're going to be looking at the ultimate guide to PLC programming for sorting operations. This sorting operation will sort 3 bottles on separate conveyor lines, creating an efficient and powerful machine. The PLC will use shift registers to track and control the position of the bottles. 2 pick-and-place robots will be used to move the bottles, creating an ultimate machine to program. Sequencers will be used within the PLC program to control the 2-axis robots. Now let's get started on this exciting project. The 5 steps for PLC program development will be followed to ensure successful implementation. This will guide you in creating this sorting operation. EasyPLC programming package sorting line will be connected to the DoMore Designer PLC simulator using Modbus TCP or Ethernet. An operator panel will start and stop. Lighted push buttons and emergency stop will control the packaging sorting line. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. The first step of PLC program development is to define the task to determine what must be done. EasyPLC software suite contains this sorting operation example in the machine simulator. This is just one of many machines that come with the software so you can learn and develop your PLC programming skills. Start the EasyPLC Machine Simulator or MS. Select the Start button on the main page or select Machines from the main menu on the top of the Machine Simulator's window. All of the available machines will be displayed. Click on the 27 packaging sorting line. This is the example that we will be programming. To the left of the screen, information will be displayed on how this process needs to function. The objective of this machine is to classify 3 types of bottles: blue, gray, and transparent. The blue bottles must be sent through the first output line using loader 1. The gray bottles through the second output line using loader 2, and the transparent bottles must continue through the main packaging line. The camera detects the bottle type, and the encoder is used to locate each type of bottle and direct it to the appropriate output line. The machine simulator has a demo mode for the built-in machines. This will allow you to watch the operation of the packaging sorting line. Select the demo mode. The EasyPLC demo mode on the machine simulator will operate, showing you the basics of operation. Move around this 3D virtual environment. The icons on the top of the window will allow you to move around this 3D environment. The first icon is the default selection. This will enable you to move around without bumping into the components. The first person mode will mimic a person in your 3D learning world. Third person is used to show the relationship of the operator to the machine. The last icon will automatically show you around this virtual environment. Once we have an understanding of what must be done, we can move on to the next step in our PLC program development. The VUIO at the bottom of the machine simulator window will display the inputs and outputs required for this packaging sorting line example. While still in demo mode, you can see the operation of the inputs and outputs. The EasyPLC packaging sorting line example will require 10 digital outputs and 18 digital inputs. It also requires 1 analog input. This will be used to determine the bottle color. The EasyPLC start mode will allow you to manually control the sorting operation machine. Exit the demo mode and enter the start mode for this machine. This is ideal if you need clarification on what output or input is doing. Select the VUIO at the bottom middle of the machine simulator window. You can manually run the machine simulator without any control or PLC connected. You can now select the packaging line sorting digital outputs on the left side of the screen by clicking on them with the mouse. The right side will show you the corresponding digital inputs. The restart button on the bottom of the machine simulator window will reset the machine back to the start. Move around the 3D environment and ensure you know what each input and output represents. Step 3. Develop a logical sequence of operation. A PLC programmer must know everything about the sequence and operation of the machine before programming. The Sorting Operations Simulator is an excellent way to learn the program. Flowcharts or sequence tables can be used to understand the process that needs to be controlled thoroughly. It must also answer questions like the following. What happens when electrical power or pneumatic air is lost? What happens when inputs and outputs devices fail? Do we need redundancy? This step is where you'll spend most of your time. Understanding everything about the operation will save you time. It will help prevent you from continuously rewriting the PLC program logic. Knowing all these answers to how the system is to react is vital in developing the PLC program. This does not have to be a formal document. You must have a method to account for every condition in the machine being programmed. Our machine has a control panel with lighted push buttons. If the machine is stopped and ready to be started, the start push button light will flash. If the machine is running, the red light will be on. If both lights are off, the emergency stop has been pressed. The packaging sorting line is reset if the stop button is pressed within 0.8 seconds twice. The conveyors all run together. This includes the main and the two sorting conveyors. The conveyors are started and stopped by the control panel, or if the correct color bottle is in the position under the pick and place robot for the exit conveyor. After the bottle is transferred, the conveyors will then start again. Bottle colors are determined by a camera located on the main conveyor. This is the photocell and an end camera signal that will be activated when the bottle has been determined. An encoder is used on the conveyor to track the bottles. This encoder includes two outputs that pulse. The encoder is wired to the inputs. Phase A and B are used to determine direction. If phase A leads B by 90 degrees, the encoder is moving one way. If phase B leads A by 90 degrees, the encoder is moving the other way. In our application, the direction does not matter. However, we can use the leading and trailing edges of the encoder phase pulses to increase the accuracy of our belt movement. Since the encoder is mechanically linked to the main conveyor, the pulses represent movement of the conveyor. A shift register is used to track the bottles along the main conveyor. Since we have two conveyors, the blue and the gray bottles will have their own shift register. A bit within the shift registers will represent the distance to the corresponding pick-and-place robot. The two robots can easily be viewed using sequence tables. At first, sequence tables may seem confusing. However, the sequence table is read from left to right. If the input conditions are met, the output conditions are set. You will see that each of the tables are similar. This is because they perform the same task. The PLC programming will involve address pointers. This is sometimes referred to as indirect addressing. We have assigned PLC addresses to the pointers, inputs, and output tables. A PLC programmer must know everything about the sequence and operation of the machine before programming. Ensure that you know what must happen will help clarify what is required in the PLC program. Ask questions or view existing documentation to ensure that you know the logical steps of the machine's operation. This may involve speaking with the manufacturer, operators, engineers, etc. Using the information from the previous steps, we can now program our Do More PLC simulator. The Bricks Do More PLC series will take you through installing the program, communicating with the controller, providing instructions, and addressing the controller. Select the System Configuration under PLC on the main menu. You can also call this up by selecting the System Configuration under the Tools menu in the Project Browser window. The computer's IP address can be seen under the Internal Ethernet port configuration. Modbus TCP server is selected by default. However, we can ensure that this is the case in the System Configuration window. Our PLC is now a Modbus TCP server to the EasyPLC Modbus TCP client. Please make a note of the static IP address that we are using for the Bricks Do More PLC. This will be used later to connect to the EasyPLC machine simulator. Our ladder logic PLC programming is split up. This makes it easier to read and program. We have subroutines for the pick-and-place robots. These will control the robot sequencers, inputs, outputs, and logical stepping. The main program will call these subroutines, and the rest of the ladder logic program for the sorting operations. Main ladder logic program. An internal bit, C0, is used to start the sorting operations. A start-stop circuit is used to control this bit. An emergency push button is normally closed coming into the PLC, shown as a normally open contact on our ladder logic rung. The push button lights are controlled based on the internal sorting started bit. If the emergency push button is pressed, this will cause both the start and stop lights to turn off. The stop light on the push button is on when the machine is running. When the machine stops, the green light push button will flash, indicating the sorting operations can start. The conveyor belt is controlled by the set and reset instructions. They are controlled by the start-stop operator panel and when the bottle is under the pick-and-place robots. Stopping the robot happens when the leading edge of the shift bits is detected for both exit conveyors. This is determined by the number of pulses coming from the encoder input. The conveyor starts again on the horizontal home bit leading edge. The camera will start when the internal sorting operation bit is activated. A shift register is used to track the bottles on the conveyor belt. The first input line or data to the register comes from the camera end bit photo eye sensor, and when the camera result has a value of 1. The 1 represents the blue bottle. The encoder leading and trailing edges are used as the clock pulse bits for the shift register. As mentioned, each clock pulse input represents the distance on the conveyor belt. The reset machine internal bit will reset all the bits in the shift register. Register bits V100 bit 00 to V199 bit 15 are used for the first pick-and-place robot. The trailing edge of the bit that triggers the first pick-and-place robot is used to trigger the reset for the sequencer operation. Another shift register tracks the bottles when the camera detects the gray bottle. This is for the second exit conveyor belt and robot. Register bits V200 bit 00 to V299 bit 15 are used for the second pick-and-place robot. The trailing edge of the bit that triggers the second pick-and-place robot is used to trigger a reset for the sequencer operation. Routines for the pick-and-place robots are called every scan of the PLC. The machine reset bit is turned on if the stop button is pressed twice within 0.8 seconds. This will reset the shift registers and robot sequencers. The leading edge of the stop push button is used to increment a register. If this register is greater than 0, a timer is started. The reset machine bit turns on if the register is greater than or equal to 2. If the reset machine turns on, the tap timer is done, or the first scan, the tap count register is reset. This is the end of the main PLC programming section. The pick and place robot sequencers are both similar and are programmed based on the information from the sequence tables created. Pick and place 1 subroutine. The actual PLC inputs are used to set up the input register for the sequencer, which is D1. The output register D11 sets the actual PLC outputs for the sorting operation. When the actual inputs equals the sequence table input, the input and output pointers are incremented by 1. The output sequence table is sent directly to the outputs. When the machine resets or sequencer reset is activated, the pointers reset back to the starting values. Pick and place 2 subroutine. The actual PLC inputs are used to set up the input registers for sequencer D2. The output register D12 sets the actual PLC outputs for the sorting operations. When the actual inputs equal the sequence table input, the input and output pointers are incremented by 1. The output sequence table data is sent indirectly to the outputs. When the machine reset or sequencer reset is activated, the pointers are reset back to the starting values. Our ladder logic PLC program is complete. Download this to the Do More Designer simulator and ensure that the simulator is in run mode. Step 5. Test the program. We will use Modbus TCP on our Do More PLC simulator to communicate with the EasyPLC machine simulator. Call up the 27 packaging sorting line machine in start mode. The status of the machine simulator will be at the bottom of the screen. Currently we have no PLC connected. Select I/O drivers on the bottom middle of the screen. The EasyPLC driver is selected by default. Under the driver pull-down menu, select Modbus driver. This driver will communicate Modbus TCP or Ethernet and Modbus RTU serial. Select the configuration button. We can now enter the information for our Modbus driver. Select TCP IP. This means the Ethernet port on the computer will communicate with the PLC. The digital inputs from MS to the Do More PLC will be MC1 to MC18. This will start at address 0 due to the offset of 1. Digital outputs from MS to the Do More PLC will be MI1 to MI10. This will begin at address 0 due to the offset of 1. We are indicating 20 digital inputs and outputs. This is fine because it is more than the EasyPLC machine simulator will require. Analog inputs from MS to Do More PLC will be MHR11. Due to the offset of 1, the PLC analog will start at address 10. Select the OK button. You will see the inputs and outputs specified for the Modbus driver. We can manually assign the driver outputs to the PLC inputs and the driver inputs to the PLC outputs. However, the automatic assignment works well and will save you time. Select Automatic Assignment from the driver option in the main menu. This will automatically assign the PLC I/O to the machine simulator I/O. Select the Start driver and exit from the main menu. On the bottom left of the window, you will see that the driver communicates to the PLC with the green light. Select View I/O to know the input and output status of the machine simulator. Ensure that the PLC is in run mode. We can now operate our EasyPLC sorting operations machine. Using the Data View window of the Do More Designer programming software, we can also watch the inputs and outputs operate. If your program works correctly, it's time to move on. If not, you'll need to debug. Since we are using indirect addressing, Troubleshooting and modifications can easily be accomplished. This can be as simple as re-downloading and re-uploading your program, or as complicated as redesigning your logic altogether. Amendments to the sequence table and corresponding PLC sequence tables will quickly change how your logic works. If the sequencer stops at a location, you can quickly see what the input should be enabled and what is currently set. This can be displayed on an HMI for troubleshooting. When using EasyPLC, debugging is quickly done with no damage to any equipment. You may modify your logic several times before getting it right. That's okay. It's all part of learning. After all, trial and error is often easier said than done. To learn more about developing logic, check out our tutorials on the 5 steps to PLC programming and development. You can practice your modification and debug by modifying the sorting machines in the following way. Calculate the cycle time in parts per minute for the machine. Add a jog circuit for the sequencer. This will allow the operator to manually step through the sequence to troubleshoot the logic and machine. Let me know how you made it in the comments below. If you enjoyed this video, please hit the like button. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is posted every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.